Hey, what's up, Chem Peeps? What in the heck are we gonna do in this vid? We're gonna use the hydrogen or hydroxide ion concentrations to calculate the pH or pOH of a weak acid or weak base solution. Pretty straightforward, not a whole lot to break down. Again, we're just gonna talk about how do we calculate pH or pOH, the hydronium ion, hydroxide ion concentrations, but our focus this time is going to be on weak acids and weak bases. A little bit different, because unlike strong acids and bases, weak acids and weak bases do not completely dissociate. They don't completely separate into ions. They create instead an equilibrium. So calculating the pH of these solutions requires consideration of unique ionization constants, so those Ka, Kb's, some stoichiometry, and equilibrium concentrations. Now, for most problems that we're going to encounter, you can simply use an ICE table to determine the equilibrium concentrations of hydronium ion or hydroxide ion to then ultimately determine the pH or pOH. Now, best way to understand this is to take a look at an example. That's just what we're going to do. Let's say we wanted to know the pH of a 0.200 molar nitrous acid solution. We're told the Ka for the nitrous acid solution is 4.6 times 10 to the minus 4. So this is a weak acid. We're not going to have complete ionization here. So we can't just use straight up stoichiometry to determine hydrogen ion concentration. What are we going to do? Well, first I'm going to write out the equation for the reaction between that weak acid and water. Then I'm going to set up my initial concentration, recognize that the nitrous acid concentration is originally 0.2 molar, initially no hydronium ion, no nitrite ion. Then think about your stoichiometry to determine the change in concentrations. Again, for many of the acids we're going to be working with, it's all going to be 1 to 1 to 1. And then finally, think about what the equilibrium concentrations will be by taking your initial concentrations and changes in concentrations into consideration. Okay, if we're trying to determine pH, we need to know the hydronium ion concentration. We need to know essentially X. So how are we going to solve for that? Well, we're going to write out our Ka expression first in terms of the species we have in the equation. Always do this first. And then plug in your Ka value and the equilibrium concentrations that you came up with in your ICE table. Now, recognize, and this is important, that many times you'll be able to do the X is small approximation. And we can do this because our initial concentration and the Ka value differ by a factor of 1,000 or more. It's going to be kind of tight in this example, but it'll still work. Now, when we do that, it simplifies our Ka expression to x squared over 0.200. And then it's just a quick jump to our calculator to solve for x. In this case, 9.6 times 10 to the minus 3. And recognize that x is our hydronium ion concentration. 4.6 second E, negative 4, close parentheses, times 0.2, answer, second, square root, second, answer. So if I want to determine pH then, now that I know my hydronium ion concentration, I'm just going to use my formula for pH, which is equal to the negative log of hydronium ion concentration, plug in that hydronium ion concentration that we just solved for, boom, we have the pH of our weak acid solution. Negative log, second, answer. We are done.